We're going to start with Copernicus. Mikołaj Kopernik was the Polish name for an astronomer and mathematician who as a student studied law, mathematics, and medicine, and then became interested in astronomy. He published an early description of his heliocentric model of the solar system in the Commentariolus in 1512. In this model, the sun was actually in the middle of the solar system, not exactly in the center, it was slightly offset. This was the first time that we scientifically had the idea of the sun as the center of the solar system. The idea was not new. Similar ideas have been proposed earlier, but Copernicus worked out how his system would work in mathematical detail. By postulating only the rotation of the Earth's revolution about the sun and the tilt of Earth's rotational axis, Copernicus could explain the observed motion of heavens. However, because he retained the circular orbits, his system required the inclusion of epicycles. Unfortunately, out of fear that his ideas might get him in trouble with the Church, Copernicus delayed the publication of them. We can see how Copernicus as a personality has influenced so much even to this day. You can see him on the bills of Polish money, and you can see him in space, in rockets. You can see him in telescopes, and even a crater on the moon was named after Copernicus. So the importance of the work that he's done is really significant. Science flourished during the European Renaissance, and fundamental physical laws governing planetary motions were discovered, and the orbits of planets around the sun were calculated. But in the 17th century, astronomers pointed a new device called the telescopes at the heavens, and this started a whole new era with so many startling discoveries expanding our universe. When we talk about space, it's almost inevitable that we go into macro-micro. And one of the things that's very interesting is looking how nanotechnology is playing a role in space exploration. There's two examples I will point out. One is in 1996, in Sudbury, Buckyballs were found in a huge crater. And this resulted in a paper by the researcher, Dr. Pereda, who was talking about a theory that comets and meteorites bombarded the Earth early in the history, and they carried these buckyballs with them. So the buckyballs, being the cage structure, could hold this helium, but it's actually extraterrestrial origin, the helium. And if a meteorite or a comet delivers this intact, the molecules arrive to the Earth's surface and survive the impact. More recently, astronomers using data from NASA's Spitzer Space Telescope have for the first time discovered buckyballs in solid form in space. Prior to this discovery, the microscopic carbon spheres have been found only in gas form. Astronomer Jan Kami and his team unexpectedly found buckyballs for the first time using this telescope. The astronomers used the instrument to analyze infrared light from the planetary nebula and see the spectral signatures of the buckyballs. These molecules are approximately room temperature, the ideal temperature to give off distinct patterns of infrared light that Spitzer can detect. Now, if we think about what's going on, where we have these molecules being detected and the idea of space elevators imagined, we can't help but to think of science fiction. In the area of space exploration, science fiction is just absolutely essential to think about when we're reading the news, we have to remind ourselves of the visions that science fiction writers have offered that scientists have followed. For instance, Jules Verne described the effects of weightlessness during mankind's first voyage to the moon in his 1865 novel, From Earth to the Moon. Russian schoolteacher Konstantin Tsiolkovsky was the first to describe a true space station, complete with a greenhouse, a laboratory, living quarters, a docking port for spacecraft, and an international crew of 6 in his 1920 novel, Beyond the Planet Earth. In 1895, Russian scientists also suggested a fanciful celestial castle in a geosynchronous Earth orbit attached to a tower on the ground. This idea was picked up by Russian engineer Yuri Artsutanov in 1960 and American oceanographer John Isaacs in 1966 and John Pearson of the Air Force Research Laboratory in 1975, before the idea of a space elevator was used in Arthur C. Clarke's 1976 novel, The Fountains of Paradise. This novel, The Fountains of Paradise, was set in the 22nd century and describes the construction of a space elevator. The orbital tower is a giant structure rising from the ground and linking with a satellite in a geostationary orbit at a height of approximately 36,000 kilometers. Such a structure would be used to raise payloads to orbit without having to use rockets, making it much more cost-effective. David Smitherman of NASA's Marshall Advanced Projects Office has compiled plans for such an elevator that could turn science fiction into reality. His publication, Space Elevators, an Advanced Earth-Space Infrastructure for the New Millennium, is based on the findings from a space infrastructure conference held at the Marshall Space Flight Center. The workshop included scientists and engineers from government and industry representing various fields such as structures, space studies, materials, Earth-space environments. And when they walked out, they thought, this is no longer science fiction. We may actually very well be able to do this. This is a big vision for nanotechnology advocates. The idea of ribbon made of carbon nanotubes was stretched from Earth into space with robot climbers hauling cargo and passengers into the Earth orbit.